Well, here we have a division problem. So the first thing I want to do before I even start trying to get rid of that radical on the denominator, which is not permitted in algebra, is I want to make sure that I don't have this already as a perfect square. Neither one of these are perfect squares. Okay. So now what I need to do is I need to see, is there any hidden factor that might be a perfect square? And for both of them, the answer is yes. So when I look at this, I have 2. My factors of 8 are 4 times 2. And in the denominator, my factors of 20 are 4 times 5. So I can rewrite this to be 2 square root of 4 times the square root of 2 over 5 square root of 4 times the square root of 5. Square root of 4 divided by the square root of 4 is 1. So those divide out to 1. So now I'm left with 2 square root of 2 divided by 5 square root of 5. So that makes my numbers smaller and more manageable. So I do not want to have the square root of 5 in the denominator. So in order to get rid of that square root of 5, I have to multiply the entire fraction by something that's going to, this is going to equal 1, meaning the numerator and denominator have to be the same, but I have to multiply my square root of 5 by something that's going to get rid of the radical. If I multiply the square root of 5 by the square root of 5, that's actually going to make it happen. Why is that? Well, let's look over here. Square root of 5 times the square root of 5 is equal to the square root of 25, which equals 5. So when I multiply the square root of something by itself, the radical disappears. So that leaves me with 2 times the square root of 2 times the square root of 5 in the numerator, and in the denominator I have 5 times what we just looked at, square root of 5 times the square root of 5, that equals 5. So in my numerator I have 2 times, because both of these are the same radicals, they're square roots, I can multiply what's underneath the radical together. So 2 times 5 is 10. 5 times 5 is 25. I want to make sure I do not have any hidden perfect squares, and I don't. One reason I know for sure is both of my factors were prime numbers. I have to make sure that I cannot simplify my numerator and my denominator, and I cannot, because 2 does not go into 25. So that's my answer.